Welcome back to a blank page to an idea, video 2A with the sequel. As you might remember in video 2, the sat-nav chip died. I think it got hit by zapped by static, and it died. So they're out the window, and in postbag 5 these arrived, the two new GPS chips, and so the story continues. Now if I kill one, I've got a spare. There we go, just turning power on. As you can see, it's acquiring satellites and the current starts high. That found the signal really quick, and once it's acquired the satellite, the current drops, and the more satellites it gets, I think it makes it a little bit higher current. But once it's got a lock, and it will turn the acquisition engine off, which is I suppose a higher gain or more current intensive processing part. So once it's found satellites, it shuts that off, and it has a lower powered section, which is the tracking engine they call it, and that only draws about 47 milliamps when that's running. And so you can see we're drawing 51 milliamps, but most of the time the LED is flashing away and it's on, so I reckon there's probably about 5 milliamps or so going into the LED, and so that's wasting 5 milliamps, so we're probably in the ballpark of about 47 milliamps drawn by the tracking engine, but still too much for what I want. So the next stage is to look at the switching power for it, so that the microprocessor can turn this on, wait till it gets a reading, once it's got the reading, turn it off, put it back to sleep, and then it won't be consuming any power. In order to switch the power, I prefer to leave the 0 volts connected. I don't want to do a do a low side switch. Oh, all my notes, I should move them out of the way. Let's make the place look untidy. And so basically we have a V supply. It's going to go along, and we're going to have a oops, oh, hey, that's drawn it round the wrong way. Let's make it look horrible. A P channel FET. So we got the source over here, drain over there, and the gate. And of course we want it to be off most of the time, so we're going to add a resistor, and I reckon about 47k, just on my head. If it doesn't work, I'll change it. So that's my FET. We call that U1, and so there is my voltage switched. Now that gives us the ability, by pulling that down, to turn that on. So we need a way of pulling that down. Well, this V supply might be higher than the microcontroller, or it might be the same, but we still need a way of switching it. And we might want to remove, we might not want to drive this level voltage straight from the pin of the controller, because if that's higher, then the current coming down here will go into the pin, it will go through the pin protection diodes to the chip supply and reverse power the supply via the 47k, and it won't be enough to drive it, but it can be enough to latch it on, or latch the inputs and the outputs, and it causes problems, so best not to do it. So then the easiest way around that is to do I run it around the right way? Oh, I'll check later. I'll check now. Pause. Well, you see time jump there as I've been away, and of course that should be down there, because effectively that's the drain, That's the source, that's the gate. There's our 0 volts going off to the GPS unit. There's our gate, and again we want the gate, we want this to be in its normal state when the micro's not doing anything, or when it's powering up and the output's not really an output. We want this to be off, so we want to pull the gate down. So, you know, random 10k resistor. We'll call that U2, give them something, and so this becomes our on off signal. Now quite often you do on/off, meaning on is high, off is low, or you can do on/, and sometimes you can put a bar on top of the off, which indicates that it's a ground or a low to turn the system off. And then, yeah, in a second we'll discuss looking at these chips. Now the thing to do is go to somewhere like DigiKey or Farnell and go through their search engines on the sites and pick up, look for a P channel FET, and what we want is a resistance from the drain source to be low. Yeah, I'm only going to pull 100 milliamps, but you know, let's look for lower than half an ohm, and we want a volt gate source threshold voltage. You know, we may only have 3.3 volts on here, so that needs to be, I think before I write, less than 3.3 volts. On here we want a N channel. RDS, well, we've only got to pull that down, so RDS, you know, could be less than 20 ohms, doesn't matter, you know, 20 ohms is going to pull that 74k right down, good enough for us. But what we do want again is VGS threshold. We want that again to be less than 3.3 volts, because otherwise, you know, if we've only got a 3.3 volt supply, then, you know, this voltage here, you know, if we're running a 3.3 micro, will at max be 3.3 volts, and so, you know, if it's greater than that, you won't turn it on. So you want the max value to be less than that to guarantee that, you know, the FET will be on. And then we'll have a look at a data sheet for the two that I found from there and talk about that. Having found a match on DigiKey, I've chose the PMF 170 XP P-channel MOSFET as maximum drain source voltage is 20 volts. I'm not going to go near that. Maximum gate source voltage 12 volts. Again, nowhere near that, and I'm nowhere near the limit of 1 amp. So that meets what I want. The resistance to the drain source when it's on has a max of 200 milliohms, but that is with a gate source of minus 4.5 volts and at an amp. Well, I won't be at 4.5 and I won't be at an amp, so I expect that will be higher. The important one is, because we're running only at sort of like, you know, 3.3 volts on the source, is that the gate drive has to be very low. And looking down here, the important one is this one, VGSTH, which is the gate source threshold voltage, and basically you want the maximum here to be less than whatever voltage you can drive it with. So this guarantees that with a gate at minus 1.5 volts, the FET will be will be turned on. The only problem is the resistance of the drain source at sort of around 2.5 volts. Well, again, 300 milliohms max. So hopefully we shouldn't exceed that. As you can see, normally as not so much easy here, but normally as the drive increases, the resistance drops. And so quite often they say they will turn on at a low gate threshold, but you find that the on resistance at the lower levels isn't as good. But here, you know, 100 milliohms difference, so not too bad. So that's the FET I'm going to use as the high side switch. Well, the same thing with the N channel FET is, you know, it's the gate threshold voltage that I'm looking for. So sometimes you see them where they say logic levels, but the logic level FETs, you know, if that's a 5 volt logic level, it may not be any good for a 3 volt or a 3.3 volt system, and that's what I'm aiming for. So again, we're looking down, we went through and we looked at DigiKey and Farnell and places like that to find a FET that's got the maximum limits, you know, greater than what we want. Yeah, 60 volts VGS, sorry, VDS, way more than I need. Threshold voltage for the gate, great, I can't exceed 30 volts, I'm never going to do that. And I'm not going to exceed 300 milliamps. So, well within that. And again, the important one, looking down the list, is going to be around here somewhere. There we go again. VGS threshold, so the gate source threshold voltage. And, you know, you see here, maximum of 2.75. So hopefully we're going to run at 3.3, so we're going to exceed that, and so that, you know, the FET will switch on. I'm not too concerned about the on resistance. As you can see, at 4.5 volts, it's in the, you know, up to 5 ohms. Higher the current, it can go up to 9 ohms. But you know, all I've got to do is pull down the source gate resistor from the P channel FET, and that I've selected to be about 47k. So, you know, 10 ohms down here makes no difference. It will pull that voltage low enough to turn the FET on. So, you know, that's important if you're pulling current, because obviously that's your losses, and that section is important if you're using low voltages to turn it on. Oh, there's the fan in the power supply running in the background, making a noise. Well, if you can see that, this is the circuit using the surface mount components just stuck on a bit of variable. Can't keep my hand still. The P channel FET is there. The drain gate, source gate resistor is there, the 47k. The N channel FET is there, and there is the 10k for the gate source pull down. And then effectively, yeah, there's a few links on the back because it was a bit easier to do it that way, and a plug. So I'll just pause and then we'll go down and I'll put it in the circuit. And here we can see the switch in action. It's well, satellite's not really pointing at anything, so it's still trying to acquire something. But this is the orange one coming down here. It's here, and currently it's pushed up to there at the moment, so this is turned on. So if I remove it, the light goes out. Put it back on again, the light comes on. So now we have a single wire that can come from our Arduino or our micro, and it will switch it on and off. I think if we wait long enough, the little light will start flashing and we'll have a signal. And so the next stage then is to modify my little Arduino program so that it will turn the power on, wait till a fix, take the fix, turn the power off. So that'll be the next installment. But as you can see, it can take a reasonable time to find a fix. So we'll just wait, possibly, and see how long it takes. There we go, found a fix. Maybe I'll go back on the recording and I'll measure how long it takes. So I think by looking at the board, I think I found a few issues that I don't like with it, the way I'm going to use it, and so I will discuss those in a minute. We have the program started. It's currently waiting for a fix. As you can see, the light is on, indicating that it hasn't found a fix yet. And currently the program just turns on the GPS power, it waits for a fix, gets the fix, and then turns the GPS off. So you witness now that the light has gone off and we have a fix. It's only seen 3 satellites. The attitude is probably about right. The speed obviously is close to 0 because it's not moving, and you know, it's pretty quick because it's a warm start. If I hit the reset button, clear the screen, let it go again, it should get a fix pretty quick. You see the lights, power's back on again. It's looking for satellites. Every 2 seconds the star moves or appears, and you know, the second it gets a fix, it will print where it thinks it is. Obviously it's going to lie because it's not going to tell you exactly where it is, because you know, I don't want people to really know exactly where I am. So that's a fake number from a location quite a few miles away. But basically that was just a quick look. You know, it's using the Arduino GPS library, but it's, you know, it's doing very little. It's just turning on, reading, waiting for a fix, turning off, displaying it. So simple. Now if you like my videos and you want to see more, you know, click the subscribe button, click on the little bell if you want to be notified, and hopefully I'll see you all again.